Thank you very much for joining me in this episode number 14 of CloudNative.fm podcast. Today is May the 11th, 2021, and in this episode, I am joined by Mitch Connors. And today we talk about ServiceMesh concept and each aspect of Istio, what make it so popular in ServiceMesh landscape, and you will also learn how to manage and deploy cloud-native infrastructure in Istio. We also spend time on how Istio is shifting its focus to be more user-centric, especially with reference to installing and upgrading Istio. 2021 is the year of the user for Istio, and this has involved reorganizing roadmap for Istio and design processes around feedback from users. The net result should be that users spend less time and energy installing and upgrading Istio and are able to invest those savings in the core value of their application. So let me introduce my guest to you. Mitch Connors is a software engineer at Google, where he works as the user experience co-lead for Istio. Over the past 15 years, Mitch has worked at F5 Networks, Amazon, and industrial IoT setups, and State Farm Insurance, giving him a broad perspective on the needs of enterprise software developers. This experience has given Mitch a passion for bringing technological innovation to the long tail of technology adopter without the need to start from scratch. Want to see what he is up to? Follow him at MITCHASHIMSELF on Twitter. And let's go ahead and say hi to Mitch Connors and cut it over to the interview. Okay, thank you everyone for joining us today. And today I'm really excited because I'm able to find the guest speaker from the Istio, and the person that I find out is a senior software engineer at Google. And how are you, Mitch Connors, and where are you working, and where you live right now, and what the weather is happening in your area?
Hey, thanks for having me, Sam. I'm really excited to be here. My name is Mitch Connors, and I work for Google, but I actually work on Istio as the user experience workgroup co-lead, and that's what I spend all of my time on. So it's a little bit different job as a Google engineer. I spend all my time in the open source community with my peers from Red Hat, IBM, Tetrate, Solo, and others.
So thank you.
Oh, you asked where I'm working from. I work from Seattle, Washington. So I have the privilege of living in the Pacific Northwest in the woods here, and it's really a great balance. I'm able to have a great career with Google and other tech companies here in the area, but I'm also able to enjoy the backwoods, lots of remote hiking and mountain biking out here, especially as the weather warms up now.
Yes, definitely. And can you tell about because of the COVID and coronavirus, everybody is now containerized in their own isolated home, and how you share your journey of 2020 to 21, how the coronavirus affects your activities of being connected with people, and what you're doing during this work from home environment for the last, I think, 1.5 year.
Yeah, my last day in the office was March 4th, 2020. So it's been quite a long time. I do think that open source projects in general, especially open governed projects, were very well positioned for a pandemic, in that all of our meetings were already remote meetings, right? Like the fact that I have coworkers in IBM and Tetrate and Salesforce and Red Hat and others means that there was never a meeting that was 100% in person. As a matter of fact, most of the people that I collaborate with on a day-to-day basis I've never met in real life. So even if I did have a Google team that was all in one office and all together, all of our regularly scheduled meetings were held online. And so the transition to working from home for most of us was, I won't say seamless, it was still difficult for a lot of people. But we were at least already we already had the practice of regularly having online meetings. If we're considering a large change, we're already making sure to evaluate it with peers who are remote, maybe in different time zones and things like that. So I think it was less painful for us than it was for some teams that were very accustomed to all being in one place.
Yes, definitely. I think that right now the open source community is keep you engaged with all the rest of the community, and that way you not feel isolated in your home. In your home, you feel to be a really fellow friendship with all the communities happening around the world in this kind of environment. So the first question, I think, from my side, because I've been with a service mesh for a very long time right now, I think spent 2 or 3 years in the service mesh category. So can you explain to our listeners who are listening to us what the service mesh is, what it has to offer, and what this current service mesh is able to solve the problem, and what type of problem is trying to solve?
Those are questions that people have struggled for a long time to define really tightly. I think it helps to differentiate between what a service mesh is and what a service mesh does. What a service mesh is a transparent network for your microservices to run on. So if you're used to running microservices, whether you're running them in VMs or you're running them on Kubernetes, we're going to take control of the network in a way that your application is not even aware of. And that you as an application developer really don't need to be aware of for the most part, so that we can do all sorts of amazing things with your traffic on your behalf. That's what it is. Then we'll talk about what it does. There are sort of 3 areas that service meshes have impact. First, as soon as we've taken control of your network, we can provide you with observability. We can start telling you, hey, here's your error rate across every service. Here's how much traffic is flowing from one service to another. Here's a graph of all of your service dependencies and how healthy they are. That can be applied right off the bat without any magic or any changes in the application code. Security also off the bat, the posture of a service mesh is pretty good. We can apply a zero trust network where every application or every microservice that you're running has its own unique SPIFFE identity and authenticates to every other application that it connects to. So you have strong identity and your network becomes much more resilient to attacks. You can also begin to have east-west traffic, that traffic that normally stays inside your data center. If you're running multi-cluster, multi-region, maybe multi-cloud, you can actually have that traffic traverse the public internet confidently because it's secured by mutual TLS encryption using SPIFFE identities. So there's a whole new level of security that it brings. And then there's one last thing that service meshes do for you, and this one you don't get for free. And that is you can do dynamic traffic routing. Probably the most interesting way to do dynamic traffic routing is to canary your services. So when I want to deploy a new version of a service in Kubernetes normally, if I roll out a deployment and it updates one pod out of maybe a deployment in size 10, all of a sudden 10% of my traffic is now going to that new deployment, and it's 10% at random. I don't have any control over which 10% it is. As a service owner, I want to be a little bit more cautious. I might want to say, hey, route like 0.1% of my traffic to this new version. And if there are any platinum users out there who are on the service, don't route them to the new canary. Maybe my free tier users are going to be routed to the canary first, because if I have an outage on my free tier, that's disappointing, but it's not a huge problem. If I have an outage where I've got standard contracts with service level agreements, etc., I need to make sure that those are not experiencing an outage. Those need to be the last things to get updated, the most stable. And so service meshes, Istio in general, but also Linkerd and Console and Kong and others, those allow you to route that traffic dynamically, which usually is used in canarying. Although we've had users get very creative with traffic routing and solve all sorts of new business problems with dynamic traffic routing as well.
Yes, definitely. I think before you've been, I think Kelsey is been in the podcast with the previously, and they have also pointed out that this conversation of engine, they have a service mesh have a save capability that Nginx has some kind of a configuration that built in, but now with the service mesh, these are now the configurable as a dynamically, and you have to take control of out of that. And now you have the Envoy as a proxy, and that is built out these kind of very great features on top of the service meshes. And I think you have covered a lot in what the service mesh is and what it has to offer. So let's point a direction to what the sideguard in the Kubernetes landscape, and what are the sideguard's capabilities, and what happening in the sideguard pattern in the Kubernetes and inside the pod.
Yeah, you're right that we did start with Nginx sort of industry-wide. If you look back 10 years ago, Nginx was, you might say, the de facto way of routing your traffic. And if you were trying to do something like a sidecar model, which basically means that you have an application and all of its traffic, rather than going straight to the network, goes straight through a network adapter like Nginx or a proxy and then to the network. Nginx was the only way to do that 10 years ago that I was aware of. HA Proxy, I think, probably had some market share then too. I didn't have as much experience with HA Proxy. I used Nginx quite a bit. The key change where everyone seemed to change focus to Envoy was Envoy was the first proxy to begin allowing changes to its configuration, changes to the way that it routed traffic without a restart. That meant that you could take a live production service and without taking that particular that particular application out of the load balancer or anything else, change the rules that it was following, and it would be able to apply that in real time to traffic. And this was the game changer that was necessary to set the stage for service meshes to take over the world. We needed the ability to give dynamic instructions to change what the sidecar or the proxy was doing without a restart, without needing to drain or impacting user traffic in any way. And that is the real magic of Envoy and why many service meshes now have standardized on using Envoy as their proxy.
Yes, definitely. And also, I think you have been the person who's been involved in the Istio project for a very long time. So it's been I think it's been a very wonderful opportunity to me to ask these questions around how the Istio is going to be evolutionize over the year from 2016 to 2021 right now. So the first question is, when the Kubernetes came into being, when we realized that we need a service mesh on top of Kubernetes. Back then, we're talking about 2016 and 2017 of the time when the service mesh concept is really originated there.
Yeah. So are you asking when we realized the need for service mesh?
Yes, definitely.
I think we'd realized the need for service mesh before Kubernetes. If you've ever tried to deal with service-oriented architecture, what Amazon was really championing in the late 2000s, the need to have consistent configuration across your services, to be able to say that my services all use the same identity scheme, that they all have the same encryption posture, that we measure them the same way so that we know when there are problems and where there are problems. It was really, really hard to do that. Spring provided a great way of doing that. If you were in a Java-only shop back in the late 2000s, Spring provided you all of those levers and tools. I think the weakness was, polyglot systems were taking over the world. Even internal to Amazon at the time, Java was the language of choice, but we were seeing growth of a lot of other languages like Python and Perl and PHP inside of Amazon itself. And so they were experiencing this pain. They were probably the first, they were sort of cutting edge at the time. But as the rest of the industry moved to service-oriented architecture, we all started feeling that pain. If you have a polyglot system, you've got 9 different ways to measure your service health. You've got 9 different ways to encrypt traffic, 9 different ways to provide identity, and getting all of those to play nicely together. And then, of course, convincing your customers or perhaps your executives that, yes, here is a comprehensive statement that describes our security posture. It was really, really hard to do. It required a lot of manual toil. So the need for service mesh predated the existence of service mesh by quite a long time. I think it simply wasn't realistic to accomplish that with the tools that we had back in 2008. We really needed that magic of live config changes without restart in our proxy. That was the innovation that enabled everything else.
Yes, definitely. I think on the topic of, because I think microservices is being the goal for every organization to accomplish. And before the Kubernetes, microservice implementation looks very daunting at first. But with the evolution of container like Kubernetes and the orchestrator engine like Kubernetes, the microservices concept is take a center stage. Now microservices can be implemented inside the container, and those containers can be orchestrated inside the Kubernetes orchestration layer. And then we finally talk about the service meshes, because the missing piece is how do we do a canary rollout or doc log deployment or the circuit breaker patterns, because these are the challenges of every application and every enterprise. And with the service mesh originated, now we are one good happy ecosystem. We have everything, and now we're ready to ship our traditional system into the microservices architecture as well. And
yeah, I like to say that what Kubernetes did for compute, that the abstraction that they provided over compute, is exactly what ServiceMesh seeks to do for networking. We want to provide those really useful abstractions over networking to allow you to really scale quickly and securely.
yeah, I think when the first version of the Istio is came up, what the first set of initial goals for the Istio team to have the service mesh, what it needs to solve as the Istio project in the service mesh landscape, and how it's being originated inside the Google and other companies. I think they are contributing to that awesome project as well.
Yeah, so Google does have some tools that sort of look like a service mesh internal. And so like many other projects around 2015, Google was seeking to take the amazing development experience they provide their software engineers with internally and make that open source. And so there was a project, I haven't used it actually because I've only ever worked with Istio at Google, but there was an internal project known as the Envelope, that wrapped Borg tasks in such a way that it could provide secure identity and load balancing and all sorts of other features that you need anytime you're running a service anywhere. And the idea was that we could take that magic from Google and open source it. And that's sort of the vision we've been executing on since then.
Yes, and I think from the starting, I think when the Istio came up, and they have some other companies like contributing to IBM, the Lyft are also contributing to the Istio project as well, and it came so much popular, so many features came up in the picture, and then we see some kind of a service mesh war coming up because people are thinking that Istio are doing so many things, but everybody not needing so many things. Some people using very little things, and when you need little things, the things going to be really fast. And then we see, I think Linkerd is also came up into the picture, and then we see the feature to feature comparison. People are talking about what it is Linkerd, what it is service mesh, what it is for Linkerd, and what it is for Istio service mesh. So can you draw a point on this, what the happening? Because right now the explosion of service mesh, I think 20 of them is already in the market. And can you reduce to the initial competition with other service meshes Istio has comparison with?
You know, that's a really tough question to answer because I don't use other service meshes much. I will say that Linkerd actually did ship before Istio. So they were the first service mesh project to publish out there. They've done some very impressive work. I actually had a talk with Thomas Rampelberg from Linkerd at the ServiceMesh Con 2020 this last year. We kind of did a chat together along with Sabine from Console Connect. And so we were able to do some of the comparison and contrast about how we've approached the problem. That being said, I'm not sure that I could really succinctly say where Linkerd's strengths are compared to Istio or where Istio's strengths are compared to Linkerd, simply because I don't use those other tools. I'm using Istio.
Okay, great. And I think on the topic of the Istio side, we see before the previous version, we see a giant monolith that the Istio have, and these are the 4 components that the giant monolith has reside in it. And in the newer version of Istio, there's a very gigantic change. I think it's a very mind shape of the change of the Istio, how it's going to be now evaluated in the next features. I think they are now they are conceptualize the core concepts of the components of the Istio project, and now they're Citadel, and they are also a kind of a microservices approach in the Istio project as well. So can you introduce what the initial version of Istio look like compared to the Istio's newer version right now we have?
Yeah, there was a really major shift in Istio around late 2019, early 2020. I think up until late 2019, Istio had very much focused on adding features. As you've said, Google is known for shipping products with lots of levers, and Istio was no exception. Some of these features were deal breakers for just a very few customers, and they absolutely had to have them, but they were very niche features. And so we had been working a lot on expanding the feature base. Around late 2019, early 2020, we started focusing less on adding features and more on stability and usability of Istio. We felt like we had a pretty good feature base, that it was pretty flexible, but that our user experience wasn't necessarily the best when installing or upgrading Istio. The first thing that we did, and I say we royally, I wasn't involved in this particular effort, but the Istio project moved from microservices to a monolith. It used to be, in 2019, installing Istio control plane involved, I think, 5 microservices. There was Galley, Pilot, Mixer, and Citadel. And that's 4. I can't count to 5 these days. And that was a lot for users to operate. It provided a great way for us to iterate or quickly and to add new features, but it did not make for an easy install and upgrade experience. If one of these 4 components had difficulty upgrading or had an outage, it wasn't clear to users what the impact on their service mesh was going to be. And so with Istio 1.5 and 1.6, we consolidated all of those components either into the data plane of Istio, into Envoy itself, which is where most of the Mixer code base went, or into one central utility we've called IstioD, or the Istio daemon, which now encompasses all of the control plane of Istio. And that has made it much easier for our users to install and upgrade and think about Istio. The next thing that we did was we provided a way for users to run 2 versions of Istio in parallel. Up until then, upgrading Istio meant first you upgrade all of the control plane components, and it's really a switch. They were on version 1.5, now they're on version 1.6. Then you upgrade each of the data planes, which is just the sidecar that's been injected to every pod in your mesh. The difficulty there is if something goes wrong, it can go wrong in very big ways. What happens if your new control plane has some subtle incompatibility with your old data planes? Now you've got traffic that's failing across your mesh, and that's really problematic. So with what we call revision-based installs, you install a new control plane with version, let's say 1.6, and it sits right next to your 1.5 control plane. At first, it's doing nothing. It's not handling any traffic at all. And then as you see fit, you can tell either one namespace at a time or one workload at a time, all right, now I want you to upgrade your data plane and begin using that new control plane. So you sort of proceed at your own pace, at whatever pace you're comfortable with. It might be 10 minutes to upgrade, or you could take 2 weeks to upgrade if that's what it takes for you to be comfortable before you shut down that old version of your control plane and are completely on to the new version. So that was a big change that we released in 1.6. Architecturally, I think that's a great plan. It's a much stabler way. We can begin to tell our users we have no downtime during upgrades whatsoever for your mesh. I do think, though, we've had a little bit of a complexity problem once again. With revision-based upgrades, we've exposed a lot of levers to our users in terms of what order, what components they need to upgrade, in terms of how do I roll back if I'm in this particular state. And that complexity can leads users to feel less safe. If I don't really understand the upgrade process well, if I can't reason about it, then I don't feel safe at any given point in time. And so we've seen that users still have a strong preference for in-place upgrades. I think there are kind of 2 halves to that. One is the complexity. The other is that some users have invested very heavily in making their in-place upgrades safe. So even though it is a point-in-time upgrade, perhaps they have 3 or 4 stages of validation to make sure that their upgrade, maybe they've got a development environment and then a staging environment that is very similar to production, so that by the time they're actually doing that production upgrade, they feel very confident that it's going to go over safely. You know, that's a valid use case. And if that's how they want to use Istio, then we want to empower them to succeed that way.
Yes, definitely. I think right now, the point that you're raising, because people have to be migrating the infrastructure into the cloud-native infrastructures and moving in that way, they need to be really feel comfortable about that. They don't want some of the complexity that bring into the table, because they are moving to the cloud native infrastructure because they think the cloud native infrastructure has some kind of moving their cloud native apps into the cloud native infrastructure. They have removed some kind of the complexity that has before in their original system. But when you move into the microservices and the service meshes, you think right now I'm very good at deploying my apps into the cloud native infrastructure with tools like Docker, Kubernetes, and ServiceMeshes. But now I have to deal with running these system and managing and deploying the complexity. That is the part of the problem. I think right now the most of the community members have said that the Istio is done a right approach in moving the pieces into their in original their own boxes, Citadel or these Citadel or Mixer and other pilot and other kind of configuration. And moving forward, I think that the next question that is driving this conversation, that I see some tools like API gateway tools and other kind of the Ingress tool and these kind of tool. And some companies have their like solo.io have done a very good job of migrating their infrastructure into the Istio service mesh. And I think on the topic of service mesh and Istio, I think Tetrate has also come up with their own program of some Istio certifications and that kind of stuff. So can you introduce these two companies and these different tools, how they fit into this Istio ecosystem?
Yeah, well, so Istio relies really heavily on vendors. There is no Istio team that you can reach out to directly for paid support. It's an open source project, and so it's equally owned and shared. If you want support for Istio, you need to look to a vendor. Google is one vendor, but there's also Tetrate, Solo.io, Red Hat, VMware. I am guaranteed to miss a few here, so I hesitate to try to list all of them. There's quite a few vendors out there. There's a lot that each of them has to offer. Solo has done a lot of innovation around WebAssembly. I've been really impressed with their work. WebAssembly allows you to run custom code in your sidecar. So if the Istio configuration and Envoy configuration does not provide you with the levers that you need in order to run your proxy, if you want it to be a very intelligent proxy in how it routes traffic or how it does security, you can use WebAssembly to author really interesting code and in a number of languages. I know Golang is supported. I think JavaScript is supported. And that will run literally in the data plane, in the sidecar, in every pod in your mesh. And Solo's done some great automation about how to distribute that code and make sure that it gets to all of your pods. It works a little bit like Docker Hub in that you're able to sort of almost declare a WebAssembly image that then is pulled down from the repository. So that was very interesting. Tetrate, I know, has done some really interesting work around troubleshooting Istio and actually troubleshooting on your behalf, so that you as the user, if you're using Tetrate's tooling, you may not need to actually do the troubleshooting yourself. They may have some automated tools for that. So each vendor brings their own unique perspective and their own unique value to the mix. And there's a lot that you can gain by looking around at the offerings different vendors have.
Yes, definitely. I think the one point that I think we're missing over the topic of WASM, the WebAssemblies model, and also we talk about the Envoy as well. So can you introduce the WebAssembly more to it? Because I think there is so many people are talking about the WebAssembly. They are so much awesome in the ServiceMesh and these kind of other IoTs and other kind of setups. And also I see a co-located events for these WebAssemblies in the KubeCon in the previously. So I think this topic is very hot. Everybody talking about it. Can you introduce this concept to our audience? What WebAssemblies is and what it brings to the Istio and the ServiceMesh?
Yeah, WebAssembly or WASM for short is probably one of it's an unfortunate name in that this is a tool that was invented to run code securely in a sandbox in your browser. It was designed to be a better JavaScript. As far as I'm aware, not many people are actually using WebAssembly in the browser anymore. However, what it turned out to be was a great polyglot tool for running code in a sandbox. And a sandbox does not necessarily need to be inside of a browser. In this case, within Istio, we found that a sandbox inside your network proxy gives you the ability to write arbitrary code that executes against your traffic, either at L7 or at L4 abstractions. So it's really like having a programmable network card that is aware of your TCP and your HTTP abstractions, which is very powerful. Now, I like to quote the Spider-Man universe in that with great power comes great responsibility. You can do amazing things with WebAssembly. I do think that we need to take a step back sometimes when it comes to all the hype and ask, should we be doing this with WebAssembly? Is a sandbox inside the proxy the right place to put this logic? Does it really need to be distributed across all of the pods in our network? Or is this logic that maybe actually belongs in the application layer in whatever language you're using to implement that? That being said, it's incredibly powerful, and the stuff that I've seen from Solo.io and others using this technology is really amazing.
Yes, definitely. I think this is a moving forward target for everybody who want to learn the service meshes. Everybody want to manage or deploy this infrastructure in the service meshes. I think they have to take a look at what the WebAssembly does and what it has to offer for you as your team, as your cloud native infrastructure is residing on that. So I think the next question we try to drive home is, I think it's been a very people are talking about ever since I think the Istio is moving to the open usage common, and then the CNCF in the whole community is talking about what happened there actually, rather than it's been a cloud native computing foundation project, is going to the open usage common project. And I think there's so much confusion around that already. I think in 2021, as of today, what happened to the Istio there, why they're moving that way rather than to the CNCF way, and what is the future of Istio open source and these kind of questions. So can you elaborate this topic of what happened there and what is the place of Istio in the open source community right now?
Yeah, those are great questions. I think CNCF really did a great job of moving open source one level forward. There have been a number of projects for years that were popular, that were open source, but were very much dominated by the company that started the project. To where if you really wanted to make a meaningful impact on that project, you probably needed to get a job with the company that was running the project. With CNCF, we saw, and Apache had been doing this for years. I think it really just exploded with the Cloud Native Compute Foundation, this trend of having open governance as well as open source to your project, that any contributor could, with enough contribution and enough sort of merit in the project, become an actual governor of the project, making decisions about where the project was going with roadmap, settling technological disputes, etc. And that is what I love about CNCF projects. I think it's a great idea. And Istio uses an open governance model as well. So if you look to the governance of Istio, we have a steering committee, which is chaired, I think 5 different organizations make up the steering committee. The buck very much stops with them. They have final say on all decisions in the project. Google is not a majority, does not hold a majority of seats on the steering committee. There's also the tech committee, which the steering committee mostly defers technological decisions to the technical oversight committee. And that's made up of Solo.io, Google, and IBM at the moment. But it's also an open meeting, so we get very frequent contribution to that meeting from Red Hat, from Tetrate, and there was one more company, Salesforce. So we hear from a lot of different companies. A lot of different companies have say in the direction of the Istio project. There's no one company that can dominate it. And I absolutely love that about the project. My own teammate, so I'm a co-lead for the user experience working group in Istio. The other co-lead is Ed Snibel. He's from IBM, joining us from New York. And I really love having a teammate that I'm able to work so closely with from another company. He brings a very unique perspective from what I bring. And so we work together really well, and I wouldn't have it any other way.
Yes, definitely. I say thank you very much for elaborating this point, because I think there's a lot of confusion in people's mind what happens there actually. When the first time I saw what happens there, because we used to see these service meshes and cloud native projects in the Cloud Native Computing Foundation, but I tried to figure out what happened there. And thanks very much for elaborating this point. I think it's removed a lot of the confusion that I already have, and all the people who are listening to this podcast. So I think on the topic of the next few questions that are really interesting for me, that I think on the public cloud we have a shared responsibility model. And what do you think, what is a shared responsibility model inside the team? I'm talking about the teams, dev teams, the prod teams, on the SRE teams, or the AI teams, MLOps team. What is the shared responsibilities of the teams if they're operating in the service mesh or if their infrastructure or reside in cloud native infrastructures using the service meshes?
Yeah, the shared responsibility model is something that really has happened because of a shift in ownership and a shift in complexity. You mentioned a little bit earlier the complexity that service meshes manage. It's important to note that the complexity has shifted. It's not been eliminated by service mesh. It used to be that every application owner needed to make sure that their application correctly handled identity for authentication, authorization, mutual encryption, observability, and did it hopefully in a way that was consistent for your company or your organization, so that the operators of the application would have an apples to apples comparison and would be able to walk up to any given application and know how to operate it roughly. That meant that the operations person's job was a little bit smaller than it is today, and the developer's job was a little bit larger. What we've done is we've shifted responsibility for defining the mutual encryption, defining the identity, defining the observability, and even to some extent the traffic routing. That responsibility now has shifted onto either your DevOps personnel or your site reliability engineers. I think it's a good shift in that they are better positioned to make global decisions about, say, observability. They're the consumers of observability for the most part. And so they're really well positioned to make educated decisions around what global observability rules your mesh ought to follow. Are you using Prometheus? Are you using Datadog or something else? DevOps are the most invested in that sort of a decision. It's not really well placed if developers are making those sort of decisions on behalf of their operations team. So it's a consolidation of that complexity into one place, but it does mean that you need to pay a lot of attention to your DevOps practices. The tools that were necessary for just keeping an application running in the late 2000s are no longer sufficient for actually running an application on a service mesh. You need to make decisions about how your traffic is routed, what load balancer strategies you use. Are you paying attention to locality if you're multi-regional? What is your security posture? The DevOps role has become incredibly critical in that sort of an environment, and I think it's a great change.
Yes, definitely. I think before the service mesh, we used to write these kind of logic like deploy canary rollout or dock launch deployment or circuit breaker patterns inside the code. So we have different tool set to manage to implement that logic. But with the service mesh, regardless of writing the logic to achieve these kind of construct, now you achieve these kind of construct on the network layer using the service mesh technologies, and that's a great thing. But service mesh has its own complexity, its own learning curve, and its own evolution as well. How it's originated, what happening there, what happening next to the service mesh, and these kind of the opinions of the people. And I think now we have to remove the complexity of writing the code. Now we have to manage the complexity of running the service mesh. I think that is a shared responsibility. And on the topic of shared responsibility, what I learned that developer have to write the code, and now operator have just one central place to manage their application, and everybody talking a single language. Previously, we have some Tomcat, Windows IS servers, and other configurations and servers. But now we are talking about just one thing, and that is service mesh. And on top of that, we achieve some kind of canary rollout, drop launch, circuit breaker pattern, and much more multi-region support and these kind of construct as well. So I think the next topic that I think you raise is what the multi-regional support in Istio, and what the do we want to use it, and what are the production use cases for the multi-regional support in Istio?
Sure. So a lot of the innovation in cloud native in general and in Kubernetes and Istio specifically has been around availability. The number one thing you need from your service as an operator is that it is always available. We've heard numbers from companies like Amazon that when their services go down, they are losing revenue to hundreds of thousands or millions of dollars. I think it's at Amazon, I think it's per second, which is a little bit mind-boggling. But even for smaller companies, the revenue loss associated with an outage is significant. The role of DevOps in keeping things running, or a site reliability engineer, is actually directly tied to the bottom line of that company. And so it becomes very critical to make sure they're available. Well, the first step in availability is 2 is 1 and 1 is none. That means if you're running 1 of something, you might as well be running none. It's guaranteed to fail at some point. All computers do this, whether it's your hard drive or your RAM or your power supply, computers die. It's what they do. And so if you're running 1, there is no safe way to depend on a singleton in your service-oriented architecture. And you need to be running at least 2 of everything. And that's great, but sometimes we have natural disasters. There are floods, there are tractors who hit fiber optic lines, there are transoceanic lines that go down for unknown reasons. And so you do see entire data centers go down. If you have a data center, even if you had 100 instances of one service in it, it's a multi-cluster, multi-regional. Kubernetes is designed to operate a bunch of computers that are all relatively closely co-located with one another. Usually we would say within one data center, or at least within one region. So if you want to run something safely across regions, you need a cluster in each region that can operate independently. And Kubernetes has had some great advancements over the years. The role that Istio plays there is making sure that your traffic can securely move from one cluster to another without worry of interception or modification. And also that your traffic route for that to go across a transoceanic cable to get from one service to another. If they're co-located in the same data center, we should prefer that item in the load balancer over the more distant links. And so that's what locality load balancing is all about in Istio.
Yes, definitely. I think the topic of multi-mesh or multi-regional support is that if we have to show that in an IT setup or everything, something has to be go down, and we have to prepare for it. And in order to be prepare for it, the multi-regional support in Istio is a way to do that. And if you're already not doing that, you have to think about that at least. What happens if some of the cluster go down in that region? What I have to do, how to route that traffic to another cluster. And I think you have to think about these issues. And I think the next question is really important for me, because I think when they're running the ServiceMesh, people are thinking about that ServiceMesh has come out the path with the observability. So do we need myself to implement the logic of Prometheus running the Prometheus or Grafana dashboard, or is the job of ServiceMesh to have these kind of dashboard, or like Kali dashboard or Prometheus dashboard, Grafana? So what is the responsibility of observability of Istio ServiceMesh, and what is the responsibility of the cluster operator?
That's a great question, and it's generated a lot of confusion for our users over the years. It used to be that we shipped a Prometheus install by default with every Istio installation. And this was because we wanted it to be very easy to get up and running with Istio. We were focused sort of on the demo use case. I want to be able to show value very quickly. And you need Prometheus, you need Grafana to be able to do that. You need a telemetry or an observability platform to do that. It could be other tools. Prometheus and Grafana are what we shipped by default. However, when you move into production with your ServiceMesh, the odds are you already have some sort of observability tooling and standards in place as a company. If you're on Google Cloud, you might be using our Stackdriver infrastructure. If you're on AWS, maybe you're using Datadog. There are dozens of tools out there that do this. And the odds are you don't want yet another one that does just Istio integration in your data center. That's not going to be valuable. You want it to integrate with all of your existing reports. You want to take all of those great signals like latency and error rates and be able to integrate them with your existing reports that might deal with transaction completion rates or click-throughs. So we stopped shipping Prometheus and Grafana by default because we found that even if you do like Prometheus and Grafana and that's what you want to use, you probably already have one. And also, we're not very good at running Prometheus and Grafana for you. We are not experts at Prometheus and Grafana. And so we found that our installation was not production hardened. It wasn't production ready. So there still is a demo profile that you can use if you'd like to have a very quick getting started with Istio that has everything you need, sort of batteries included. You can use the demo profile and get Prometheus and Grafana and Kiali and all sorts of other things installed But when going to production, you should really consider how to get that telemetry data using the Open Telemetry API into whatever your company's existing observability platform is. You shouldn't be having a separate observability platform dedicated to Istio.
Yes, definitely. I think the very good topic, very good point you raised here, because I think there's so many confusion around that. I have already Istio and ServiceMesh is like Linkerd. They have a Prometheus built in. Why do one I care about it? I think people thinking about the job of their ServiceMesh is to have, but I think it's not a job. I think the ServiceMesh tells you the importance of Prometheus and Grafana. If you don't learn about these two technology, they give you the importance of what the Grafana and Prometheus is. Because at the end of the day, I think in the cloud native and the container world, there is so many observability and monitoring point. It's in the container, it's in the host operating system, it's in the cluster, it's in the cluster outside the boundary, and these two cluster associated in two different regions. So there is so much observability and monitoring that you have to cater for. And don't think about that the Istio or the other service meshes provide you. They give you some kind of a starting point. Now you have to think about how to go forward with that observability.
It's very important to have the right tool for the job. And a service mesh's job, one of its jobs, is to provide telemetry data. Actually interacting with that data, recording that data, viewing that data, maybe alarming on it, is not the responsibility of a service mesh. There are way better tools out there for that job, and you should use those. They're awesome.
Yes, definitely. I think before I let you go, I think one question is always popping in my mind. What is happening to the cloud? I think we see cloud every public cloud have AKS, EKS, GKE, and these kind of offering. So do we have to see in the GKE or other public cloud to see the Istio manage Istio services or other kind of services in popping up in the cloud, or or in the roadmap, in the current roadmap of Istio having integration with some public cloud providers?
Yeah, so most Istio vendors are pursuing or already offering some version of a managed Istio service, and what managed means is still taking shape across the industry. Here at Google, we have Anthos Service Mesh, where we manage some components of your Istio Service Mesh on your behalf and provide support for it. I know IBM also has similar products. Tetrate, VMware, many companies are moving in this direction or already have moved in this direction. And I recently sort of got an insight into why that is. I started talking to users about why they weren't upgrading Istio as frequently as we expected them to. We found a lot of users were on unsupported versions of Istio, or even versions that had known critical vulnerabilities. And they were still running these in production. So I tracked down a few of these users and started talking with them. And what I realized is that if you've bought into the cloud native landscape in open source and you're running everything your own, you need to have a telemetry system that you're running on your own, an observability system that you're running on your own. You need to have a data analytics system, an orchestration system, a service mesh system, probably one or more database systems. It becomes overwhelming really quickly. Sure, maybe you only need to upgrade Istio like twice a quarter. But if you need to upgrade each of those components twice a quarter, you now need to hire a team whose full-time job is just upgrading all of this stuff. And those skills are in very high demand. Knowing how to upgrade a Kubernetes cluster safely, an Istio service mesh or a Linkerd service mesh safely, Prometheus safely, those are not skills that have been around for years. No one has a master's degree in upgrading CNCF tooling safely. And so it's very hard to hire for. These companies are facing a serious labor shortage. And so the way that they're able to compensate for that is by reaching out to managed products. Most cloud providers now will provide you with some sort of managed open telemetry system, managed service mesh, a managed orchestration, and that relieves a lot of the pressure on the company from being an expert in all of these different tools and allows them to focus on what they're really good at, which is their particular business domain. And so I think that's great.
Yes, definitely. I think that's a target point for many of the vendors, and to go to the public dashboard, because at the end of the day, there is so in the cloud native landscape, people's already scary about the learning curve of these projects. Like containers with Dockers have their own learning curves. Kubernetes has a giant learning curves. We all know about that. And then
Yeah.
is also have a giant learning curve as well. So if I want to use these awesome projects, awesome cloud native infrastructures, what I do, I have to come up with a solution that somebody have some kind of managed services. At the end of the day, I am consuming that services. So that's a fastest way to implement cloud native infrastructures in Istio and Kubernetes and Docker and these kind of stuff. So I think
Yeah.
we covered so many great things, and thank you very much for Mitch elaborating these points in a very detailed and very in a way that is easier to grasp and easier to understand. So last few question: what you see, what is coming up in 2020 in Istio world, and compared to comparison to the past, what is moving forward in the Istio community, and what to watch out for if we are using Istio Service Mesh in moving forward.
I'm really glad you asked. So that signal that I talked about getting from users that Istio was hard to upgrade, that they were hesitant, has really resonated with the project. It's changed completely our release roadmap for the last 2 releases. We're shipping Istio 1.10 next week. 1.9 made some serious improvements to upgrade stability, and 1.10 should do the same. In particular, what we're doing for users is we're separating out gateways from the control plane upgrade process. So now when you upgrade, if you want to do a safe upgrade of Istio, there are 3 components to think about: control plane, gateways, and data plane. And each of them can be moved independently at your own pace so that you feel safe in that upgrade process. We want to make sure that our users feel comfortable doing upgrades because they are something that you need to do to your service mesh fairly often. Vulnerabilities in Envoy or in a service mesh come out a handful of times a quarter. And if you're going to stay protected, you're going to need to feel comfortable doing at least those small security upgrades. And then eventually you're going to need to feel comfortable upgrading to the next minor version to stay within the support window. That being said, we've heard our users. Upgrading is still hard. No matter how much work we put into it, upgrading is going to be risky. Service meshes are an incredibly important component to your infrastructure, and upgrading an important component always feels dangerous. And so for the first time in Istio 1.10, we are going to support skip version upgrades, which means you will be able to upgrade from Istio 1.8 to Istio 1.10 without you going to Istio 1.9 in between. Our intent is that in the future, you will not have to upgrade Istio on a minor version every quarter. If you want to upgrade only once every 6 months, we're going to begin supporting that. We're also interested in hearing from our users how often is the right amount. How often would you like to upgrade your service mesh? Once a quarter, we've heard loud and clear, is too much. Is once every 6 months a good number? Should we be looking at once every 9 months or once every year? So if you have feedback about that, the user experience work group meets every Tuesday at 3 times a month, and then 1 time a month we'll meet on Wednesdays at an Asia-friendly time. So go ahead and look at our community calendar. It's at github.com/istio/community. And feel free to jump in the meeting and tell us how often do you want to upgrade your service mesh. But that's where we're headed. Where we're headed is hearing a lot more from our users and paying attention to the feedback we're getting and moving into a direction that is more sustainable for them.
Yes, thank you very much. I think that's really appreciated because I think we see a same conversation is started in the Kubernetes community as well, because they have a 4 releases a year now. They have contracted themselves to 3 releases a year, and I think the same conversation is started in the Istio project as well. So I think the one last question is from my side before I let you go. I see SMIs are popping up in the service mesh landscape. So can you elaborate a few words on what SMIs is and what the Istio's contribution to these SMIs project, or do we actually want to need it?
Yeah, so Istio has not contributed to the SMI project as a whole, but several of the companies that are contributing to Istio are also contributing to SMI, most notably Solo.io. The idea behind SMI is there's all these different implementations of service mesh. What if we could come up with a generic API by which you could control any of them and seamlessly move your application from Istio to Linkerd to Consul to Kong or others? I think it's a really cool idea. Generic APIs have had a huge impact on the industry. Certainly the dominance of the Kubernetes API over orchestration has been very valuable. I'm curious to see how SMI evolves over time, because one downfall of generic APIs is the least common denominator problem. When you're trying to have 19 different implementations of one API, it's very difficult to add a feature to that API until all 19 versions support that feature equally. And that's not something I'm seeing in ServiceMesh yet. Service meshes don't have parity with one another. There are features that Linkerd has to offer that Istio doesn't, and vice versa. And that's true of any two service meshes that you could compare. So having a generic API across all of them is a great idea. I would love to see it work out, but I think we're going to have to wait and see how they handle the differences between all of the implementations they've got.
Yes, definitely. I think a very good topic you raised out here, because people are trying to ask, we have a generic API of for 19 different service meshes. If they end up adopting these generic API, who end up left with just a one service mesh rather than just a 19 of them. So it's a kind of a difficult topic to grasp for the people, what's happening inside the SMI. But I think SMIs is a way to go for if you want to interesting in this landscape. Go take up a look at it, and and go inside with the SMIspec.io is a website for you to search for the people who are working in that area. So before, thank you very much, Mitch, for connected with me. It's been a pleasure talking to you. It's been a dream for me to talking to someone who are building that Istio great project and talk to him what he feels about the project, what is to share his knowledge for my community, Cloud Native Islamabad. And thank you very much, Mitch. And as you let you go, can you describe 3 words what the past, future, and past, present, and future of Istio Service Mesh in a very few words?
Oh, let's see. Innovation, stabilization, and so innovation in the past, stabilization at present, and in the future, we hope to be boring.
Thank you very much, Mitch. It's a pleasure talking to you. Hope to connect with you again in future. Thank you everyone for joining our podcast, and hope to catch up Mitch Connors again. And thank you everyone for spending us time with us here. Thank you.
Yeah, thanks, Saim. Have a good time.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.